Hello everyone, welcome back to the channel Data Science with Harshit. So this is the final part of the end-to-end machine learning project series where we are going to learn about model deployment using a Flask Web framework, and we're going to deploy this application on Heroku. So I would not be building a complete web application as such. We would simply be developing a mere backend of a very simple application. So what the application would be is it would simply be that you will be sending your let's say vehicle configuration onto a server. You'll send a post request on a particular route, and that particular route will compute the predictions using the model that you have deployed, and it will give you the result, which is the MPG prediction, fuel consumption prediction of the vehicles that you have sent onto that particular model. So let's get started with Flask and how we can develop the application backend using the code from our Jupyter notebooks. So to deploy a trained model, we need basically two things. Two things are required. One is the web service through which we'll be handling the HTTP request and response. And the second thing is we need a cloud platform as a service. So where we can deploy our application so that everyone in the world can basically use your trained model. So for the web service, we have chosen Flask. It's a lightweight web framework and it requires minimal coding to get started, and it also takes care of all the complexity that is there behind handling HTTP requests and response objects. So we don't have to worry much about that. So Flask is something that you can really pick up very easily. And for the cloud platform, we are choosing I have picked up Heroku because it's very easy to get started with, and also at the same time you just need a set of commands to deploy your application. You don't have to worry about a lot of different things, but most of the bigwigs, the companies in industry, we use either Google Cloud Platform or AWS, on which Heroku is built. So you have basically, for these projects, for learning purposes, we try to keep things simple, and thus we use Heroku. So I have jotted down all the points that we are going to need in order to deploy our application. So first of all, we need to set up our Flask project. So basically create a dedicated directory for the Flask application. Then we are going to create an environment with all the dependencies installed using pip. So I'll just walk you through all of those commands and everything, how to set up your environment. And then third step is to create a quick Flask application to test a simple endpoint. So we're going to see if our Flask application is everything is working or not. Then we are going to load the model and create predictions out of it using the functions that we have written in part 3 to pre-process as well as transform our data. And the fifth step, the final step, is to basically test the endpoint. Once we have everything working on local server, we are going to then deploy it on Heroku and then test if our deployed URL is actually working or not. Is it giving us the predictions or not? You might run into a few errors. There might be a lot of back and forth. So don't worry about it. Keep looking at the logs. So that's a must when you are developing the backend of any application. So when you're going to full stack or web development, this is something that you'll have to deal with. So try to find out the reason for why it's not working. You'll have to do a lot of Googling and everything. So that's the realistic. Even if I get it done on the video because of the time constraints, everything in just one go, it's because I have practiced it before. So keep that in mind. All right. Let's see what we have. I have created this Flask app. So I have this dedicated directory. If I ls, there's nothing in this directory right now. So first of all, what I'll do is I will create a virtual environment. So for that, the command is basically sudo python 3 -m I'm creating virtual environment and I'm naming it as, let's say, flask underscore env. All right, so this will basically set up the environment for us. All right, so our environment is set up. Now we need to activate our environment. So the command for that is, so first let me show you. So we have this flask underscore env directory which has been created for us. So there are some other directories in it. First of all, what we need to do, we need to activate this environment. Source flask underscore env, and by the way, I am using VS Code to code my Flask application. So flask env bin activate. So this is the command. This will activate my environment right here. So if you cannot see, so this is where basically I'm creating. So right now you should just focus on the terminal. So I've activated my environment. The next thing that you do is you need to install all the packages that I have talked about, this particular list. So one by one you can either do this, pip install pandas numpy, hit enter, and this will install all these packages one by one. All right, so we have all of our dependencies now installed. We can quickly see all the packages that are installed in our environment by using this command called pip freeze. So hit enter and it will show you all the packages that are currently available in your virtual environment. So great, we have everything set up. Now it's time to set up our directory structure. So let's look at this. So currently I have only my environment in this, which is something that pip manages. So we don't have anything to do with it. Now with this file, first of all, we are going to create a main.py where we are going to keep all of our Flask code. So main.py, this is our main.py in the main folder. That will contain our Flask web service. And what we are going to do first of all is we are going to import Flask because that's the application. So from Flask we need to import Flask. So that's done, easy. And now we have to instantiate this Flask, create a Flask object, create an application. So we call it app and instantiate it using, let's give it some name, mpg, let's call it mpg underscore prediction. So that's our app. Now we need to first define the route, basically the URL to which we need to send a request, HTTP request. So let's first we'll check if our web service, basically the application, is working or not. Let's create a random route. So let's call it, let's say the main URL, the base URL. Let's create a function for that, and this is going to be an HTTP GET request. So there are different type of requests. You should read a little bit about GET request, POST request. You can send data in POST request, but you cannot send data in a GET request. So this is just to test if our application is working or not. We are simply creating a ping function, and what it does is it simply returns a message which is pinging model application. So this is the message. So if I go to this particular route, so this should ping model application. All right, now if I had to, so to start this particular application, to start the localhost server, we need this boilerplate code. So the code is, so this boilerplate code here, the run method basically contains, it starts our web service. The debug true means that as soon as I save anything in my structure, basically my server should start again. Host is 0.0, so that I make my application public and I can access it from anywhere, and I'm using the port 9696. So this is like the boilerplate code in order to run your, in order to start your web service. So this is all set. Now I think I should be able to run my Flask application. Quickly let's clear our terminal. Now I need to run this module, this file, python main.py. Let's hit enter. My application is currently running on, so you see this, you have to just copy this link, paste it in your browser and hit enter. So you see that we have pinging model application running for us. So it has printed this pinging model application, which means that our application currently is running smoothly. Now the next thing that we have to do is to go back, and now we have to make the model work. So we have our trained model. So let's create a directory structure for that. Now I need to create another folder where I will keep all of my model related files and model related code in this particular directory. So I've created this model files directory. Now in this directory, let's create a new file. Let's call it ml underscore model.py. This is my model.py, and I will, so the trained model that we saved, we should move that model here in this particular directory. So for that, let's shut down the application for a bit. And so here I am copying my model.bin file from my other project folder into this model underscore files. So I'm copying from my ml underscore end-to-end folder. There I have model.bin file, and I want to copy it into my model files, this particular directory. So hit enter, and I have model.bin here in my model underscore files. Now one other thing that I have to do in this particular folder is I have to create a new file which is called underscore underscore init underscore underscore dot py. This is just to make it a module so that I can import anything that is written in my ml underscore model.py. So here I will be writing a few functions that we wrote in part 3, which is pre-processing, transformers, and the predict main wrapper, which is the predict mpg function. And what I'll do is I'll import that predict mpg function in my main file. So let's first create the ml underscore model.py. So here what you'll need to do is you'll need to simply copy all of the, first of all, the libraries that you need. So let's copy the libraries. So these are the packages that I need. So let me just simply copy this, copy paste all the packages that you have used in part 3. This is good. This is just a single step. Now what I need to do is I need to write functions here. So the first function that I have to write is the preprocess function, which is what I am doing. So firstly, we are going to preprocess, copy paste the preprocess function. This is good. Then the next thing that we have to do is prepare our transformer. So here we are going to copy this custom attribute header first of all. This is all fine. Now the next thing that we have to do is add the two function, numerical pipeline transformer and full, the complete pipeline transformer. So here copy everything and paste all the two functions. Now the last function that we have to copy is the main wrapper function, which is the predict mpg, the function that I wrote at last. So this is my predict mpg function. I'll copy this, paste it. So my model, this will basically what will do, pre-process first the raw data, pipeline transformer, and then predict the result and send the predictions. So save this ml underscore model. This is basically the function predict underscore mpg, which I'm going to use. I haven't written the documentation for this, the doc strings. Please make sure that you do that. That's a best practice. So now what I'm going to do is I'm going to change my main.py. I'm going to use the code that I've written in my ml underscore model.py. So first of all, what I'll do is I will, from the model underscore files dot ml model, I will import the predict mpg function. That's what I'm going to do. And to read my model file, this is model.bin file, to load my model, I am going to use pickle as we saw in part 3. Now what I'll do is I'll create another router which is app.route, and let's create it for the main URL. Let's comment out this. For the main base URL, I am going to create a method post request. So I'm creating a post request method route so basically to this URL, if I send a HTTP post request with some data, what should I do? I should be basically predict, and let's call it simple predict. And then what I need to do in this function is, first of all, I need to capture the vehicle configuration that the user must have sent it on the server to extract some predictions. So first of all, get the user data from the request, from the post request. So for that, we will first capture our vehicle configuration from, we need to use the request class, and also we are going to need JSONify to finally create our response. So to capture the data from the post request, we need request dot get underscore JSON. This will capture all the data that has come from the request. Now next thing that we have to do is we will have to read basically load the model. So for that we need to open the file which is in the model underscore files directory. This is model.bin. Read it and as f underscore n. This is the same code. Read the file, load it into a model, pickle dot load and f underscore n input file. Close the file now. So a model is now loaded into this variable called model. Now the next thing that we have to do is the predict mpg function. What does it take? It takes the vehicle configuration and the model. So simple, it's time to make some predictions. We will call the predict mpg function, pass the vehicle configuration and the model. This will give us the predictions. Now we need to create our response. So response would be our dictionary. Let's call it mpg underscore predictions. So corresponding to this key, we will add all the predictions that would have come into this variable predictions that we have defined over here. So our predictions, this basically our response is ready. Now before we return it, we'll have to JSONify it. Basically this class, this function, it represents the JSON representation of the response. So this is currently in my Python dictionary format. This will create a JSON object and then return as an HTTP response. It creates a MIME type for that. So JSONify is all fine. Now pass on the response to it and it will give you the result. So this should work now, and let's try to run this. Save the file. So we have everything ready. Now let's open the terminal. Again, python main.py. Let's run the script. See if this works. So our server has started. Now in order to test whether our URL, the post request, is working or not, we'll have to send data. So for that we are going to use our Jupyter notebook. Make sure that you have a request package installed in your virtual environment, the one that you are using for your Jupyter notebook. So let's copy this URL over here. Now what I'm going to do is here we have imported the request package, which is basically used to send get request and post request to a URL. You can also use Postman to test out this endpoint. So I've imported the request packets of, first of all. Then this is my URL to which I want to send the request. Then the next line I have request.post, so I'm sending a post request to this particular URL, and the JSON, the data that I want to send is vehicle configuration, which is defined over here. So this is my vehicle configuration. So this is the one that I am going to send, and these are the predictions for it. Now let's see how our Flask service is able to send the same response or not. And then at the end, I am reading the text. Basically, this request object that I will get, I am basically simply stripping it of extra codes and all those things. So you run it and you see that your URL, your Flask application, this is the result from your model, the learned model, the trained model that you have. So this is all working fine. Now if you compare it with these results, the results are also fine, the results are accurate. It's time to now deploy this application to Heroku. So for that the steps are simple. So first of all, what we'll do is we'll shut down this application for a bit. Now, in order to deploy your application on Heroku, you need certain files. Now, those files are basically, first of all, you need a file called proc file. So let's create a proc file. So the spelling is PROCFILE. So create a proc file because this is needed so that you can send the commands. These are the commands basically in order to start your web server. So we need to start a web server. And if you remember, I asked you to install a Unicorn package. So Unicorn is a Python HTTP server for WSGI applications, WSGI applications, which is basically web server gateway interface application, and it provides the flexibility, the balance between flexibility, performance, and the usage of all the resources of your cloud computing platform. So for Heroku, most of the applications use Unicorn to run their servers, and so that it can handle multiple processes at the same time. Now we have Unicorn. The next after this you have to add as a WSGI file. So this is the command in your proc file that you have to add. Now we are going to create the WSGI.py. So inside this, all you need to do is, first of all, from the main, you have to import your application. So the app that you created in the main file, this is basically the app. So here you simply have to run this. So if the name is main, so you have to call app.run and it will run the application for you. Save this file as well. Now the next thing that you need is to deploy your application is requirements.txt. So all the packages that you need on your server, this should be present in your requirements file. You can use pip freeze or you can use the list that I provided you. This is the list of all the packages that we are going to need. Simply pass it on here, copy paste it and save it. Now these are the steps. So I'm going to move into my bigger terminal so that I can show you what are the commands in order to deploy your application on Heroku. First of all, if you do not have an account, please make sure that you have an account on Heroku. Now I have an account already. So first of all, this is my project folder. This is where my application resides. If I show you all the files, these are the files that I have. Okay. Now the first thing that I have to do is initialize it as a Git repository. So this is Git init. Now the second step is to add everything except my Flask environment. So I have to add everything here. Proc file, requirements.txt, main.py, my models file folder, my WSGI.py. Is there anything left? Alright, so let's check the status. So I don't want to add this environment. This is for my local server. basically local machine. So I am going to commit these changes, commit git commit -m message. So this is my initial commit, and now I am going to push all. Okay, before pushing, now the thing is, first you have initialized and committed all your work. Right now the next thing that you have to do is you have to make sure that you log into your Heroku account. So first thing that you have to do is Heroku login. So hit some key. So this will open up a page on your browser. Click login. Now this shows you that you have logged into as Harshit. This is my email address. Okay, so I've logged into my Heroku account. Now the next thing that I have to do is I have to create an application. So name the application Heroku, create application, and let's call it prediction fuel. So this is the name of our application, and it will create a base URL based on this. So let's create a Heroku application for this. So our application is also created. Now the only step that is left to deploy our application is to push your code. Our repository all set. I want to do git push Heroku master. That's it. So my application is created. All I need to do is push my code, git push Heroku master, and it will deploy my application onto Heroku. All right, so our application is now successfully deployed. You can see here it is deployed. It's right here. HTTPS prediction fuel efficiency Heroku app deployed to Heroku. All right, so what we're going to do is we are going to copy this URL. So to this URL we have to send a post request, if you remember. So what we'll do is now we will replace this URL and paste the deployed URL. So this is deployed, and this will go into my URL. Same, I'll send a post request to this URL along with my vehicle configuration. You see these are the result. Now if I run this, I should get the same result. So you see this is the same result that we are getting, but from a deployed link. Now you can imagine what would be the next steps. You have everything deployed. You can send request, send your data, and get the deployed the predictions from your trained model. So that was your deployment process. Heroku gives you a free account, so you have you can deploy up to 5 applications for free. You can do that, and there are few priced services, but you don't need that. And in order to deep dive into deployment, DevOps, and data engineering, creating pipelines, so that I would be covering in the data engineering series, which would come in later. All right. So we have come to the end of our end-to-end machine learning project series. I hope you all found this entire series useful. You could build something out of it. Now the next steps that I would recommend that you do is pick up some more complex data and stick to the task cheat sheet that I have provided in the description, and carry out all of those steps one by one, and create an entire application out of your project. So that would be the next steps. And if you have found this entire series useful and you want to see more stuff like this, please comment down your suggestions so that I could read them, and maybe I could come up with another project idea. So the next one, I think I am working on a TensorFlow deep learning end-to-end series, and please feel free to comment down below your suggestions, and I will try to build something based on your suggestions. Now if you found this video useful, again hit the like button, and please subscribe to the channel. That will help me and the channel grow. So I'll catch you in my next video. Up until then, keep learning data science with Harshit.